So some of you still need to start your project. So some of us still need to start a project, which I don't know where we've been all quarter. Because that was assigned at the beginning of the quarter. You don't have it, you haven't even started by now. Looks like you're not going to sleep this weekend because you got a lot to do. Yes, Miss. All right. So here's where we were. This is where we stopped from last time. So I believe it is, I think it's slide 11 or something, or slide 12, somewhere around there. I know it's the top of a page. So this is the page where we should, oh, maybe it is the bottom of the page. Okay. So it was after slope. So basically side lengths in the range of a third length. So basically what's going to happen on two of your problems. One problem, I'm going to tell you, can these three numbers, given three numbers, can they be a triangle? And if they are, you can tell me why. The reason being, take your two shorter sides, add them up. If it's bigger than the longest side, it works. So if you look at these three numbers, 17, 11, 24, what are the two smallest numbers? What two numbers are the smallest?
11 and 17.
Okay. If we add up 11 plus 17, we add up 11 and 17. Well, what is 11 plus 17?
28.
11 plus 17 equals 28. Now, is 28 bigger than 24? Okay, so then it works. So since that's a yes, this can be a triangle. These, yes, can be a triangle. So you can just write yes, can be triangle. Now watch the order. These two are obviously smaller than the last one. Well, what about the next one here? Yeah. What does that equal? What's 15? 33 bigger than 34? No. Not a triangle. That's all you have to do. Okay, questions? Okay. Now, over here, let's say I give you two numbers. To get the third side, all you do is the following. What's 20 minus 12? 8. Then, less than x less than, what's 20 plus 12? Hey, you don't need that phone. Class is started. If you want to lose your phone, let me know. I will make that happen in a heartbeat. So it's 20 plus 12. That's all you need to do. So if I give you the two numbers, if you need the third side, add them up. Well, actually subtract them first, then add them. And that's all you do. That's all you do for this type of problem here. Same thing with the bottom. Now be careful. 11 and 25. Do you do 11 minus 25 or 25 minus 11? All right, because I remember on the original test, A lot of you did 11 minus 25 and wrote negative 14. No, you have to flip it. 25 minus 11. And then you also have to do 25 plus 11. So what is 25 minus 11?
14.
And then what's 25 plus 11?
26.
That's all you do. So for these types of, you're going to get one of each. So so if you're given 3 numbers, hit the 2 smaller numbers, see if it's larger than the biggest number. If it is, you have a triangle. If it isn't, not a triangle. Same thing here. Here, if I only give you 2 numbers, subtract, add. So you got your study guide from last class. We're continuing from where we are. Okay, questions on this activity here, for this particular problem? Okay, what happens here? Okay. Here we go. Good, everybody? All right, now, some of you haven't done it in a while. Triangle congruences. Your order matters. Order's going to matter for these types of problems here. Order of the letters. So if you look at your diagram, notice you have triangle ACB. Now you need to look from the first triangle. You need to look at, okay, notice how you have angle A. Is there any angle markings? Okay, we should be looking up front. You want to pass the final? Do you want to pass this class? All 3 of you. If you don't, let me know. All right, so let's zoom in. All right, look at triangle ACB. Now, the order matters because here, what I need to do is I need to match, for instance, with angle A, which angle out of P, Q, and R matches with angle A. I'll give you a hint. Look at your diagram. Look at your markings for each angle.
PRQ.
PR. Why is it going to be PRQ?
Actually, CQP. I mean, RQP.
All right, so actually, you should have went with your original. You're right with the original because A matches with P. Because there's no marking for A, no marking for P. And then C matches with R. See the arc with a single little tick mark? C and R have the same exact marking. And then, of course, B and Q have to match. Because in the end is you want it to be such that when you write your ABC or ACB in this case, you want to make sure that angles on the top or the sides and the angles on the top match with the angles or the sides on the bottom. That's how you can tell. Now, why are these 2 triangles congruent? Again, look at your markings.
Slash.
Okay, what's that?
Slash mark.
That's going to help, but what particular reason? Because you have side, 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 angle, 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 side. What's the particular reason in this case why these two triangles we could say are congruent? It is angle, side, angle. Because C and R, there's your angle right there. That's one of them. Here's your first angle. And in between the other angles, that's a side. And then, of course, last angle. Last angle here. So it is angle, side, angle. You might have that on the final. Let's say here's a triangle. What's our order? Y. Okay, questions on this problem, ladies and gentlemen? You understand why this is an angle, side, angle. All right. These next two problems. Given a diagram, you're going to have to tell me which triangle congruence will work. Now, let's start on the one on the right. For both triangles, what are marked? What are marked in all three cases? What do we have marked? Sides. So which one has all three sides? All three sides. SSS. Very good. That's the first one. Now, we look at this one. So this one's straightforward. Side, side. Second side, third side, third side. That's going to be straightforward. We see that one, right? But what about this one? I only have two sides from the triangle on the left with two sides for the triangle on the right. And you could say you have a mirror reflection taking place here. Oops. Pretend this is your mirror. It's being reflected, So I have two sides so far. So this side matches with this side. This side matches with this side. Now, do we know whether or not this third side works? We don't know. So we can't exactly say SSS. Do we have two? How many? Now, what do we know about this angle here and this angle there? Vertical angles, which means they are congruent. So since this angle is congruent to this angle, side angle side. That's what you have going on here. That's a side angle side. I guarantee you, you're going to get a problem like this in your final. I guarantee it. Hint, hint. You might want to remember this for your final. All right, any questions so far? Oops, didn't mean to do that. Okay. There we go. So basically with triangle congruences, know your order. Know the order and know what's given to you. A lot of us, some of us got this, some of us struggled because some of us, I remember, you had a side, a second side, only one angle, but some of you are writing angle side angle. That can't happen, especially when you already have two sides marked. Or we had two angles marked, but some of you wrote side, side, side. Again, watch your order. All right. Questions before we go to the next one? All right. Next one. You have three angles in a triangle. Some of your three angles add up to 180. So angle J plus angle K plus angle L add up to 180. So now this is going to be a two-part problem. Now again, on some of these problems on the final, you'll get partial credit. So let's say I gave you a problem like this. You set it up. Okay, you got a point right there. So 2x for angle J plus x plus 12 for angle K plus 96 equals 180. Okay, you give me a setup, that's going to be some credit. You might get a point out of 4. And then if you solve for x, that's going to be 2 more points. So look at our x's. Are they on the opposite or same side? So that means just add them up. So 2x plus the other x gives us how many x's? 3x. Again, some of us were minusing x on the same side. You couldn't do that. Then you add the 12 and the 96. It's 108. You add them up. And then the grand total, sum of the two have to equal 180. Now, are we at a point where we can solve for the x? All right, I want y'all to find that real quick. Should only take you about a minute. All right. All right. What do we get for x? Who could tell us what our x value is?
24.
How much?
24.
24. Agree or disagree with the 24? All right. It will be 24. It's here, minus 108 on both sides. And then you get 3x is 72. And then you divide both sides by 3. And that's how you get 24 for x. And then you plug your 24 into the x plus 12. So then what's 24 plus 12? How many degrees? 36. There you go. So this would have been the first point right here. Get your setup. You got to get your setup right. You don't get the setup right, game over. Then from there, simplify, solve. That would have been 2 points right here. That would have been, so here would have been your first point, here would have been your other point. And then your last point would have been plug the 24 into the x, solve for the angle, boom, there you go. Questions?
Mr. Why do I have an
We could talk about that later.
Then I put in my project.
We'll talk about that at the end of class. Yeah. Okay. Here we go. Questions on this problem. And again, the sum of our angles in a triangle adds up to 180 degrees. That's the most important step. If you don't get that part, that's a problem. That's going to be a major concern. TA and 1. Thank you, Mr. Madden. Yep. And also, today's going to be the last day for stingers. Now, I'm available for both TA and Stinger 1. So if you need to take care of anything, talk to your TA or your first period. I'll probably be in here. All right, questions on this problem? Now, the next problem. We're going to need some extra concentration. There's a lot of work going on here. So, what I told everybody at the beginning, whenever you have a triangle congruence statement, take your first triangle statement, take those three letters, CDE, put it directly over your second triangle congruent. Go see Mrs. Ned and then give that to me. That's fine. Thank you. Whenever you have your triangle congruence statement, put the first three letters over the second three, and then that's going to tell you which angles match with which other angles. So for instance, notice how CDE is over GHF. So therefore, now we can figure out who matches with who. So with angle C, which angle is going to match with angle C? Look on top or look below. G. Now, what about angle D? H. What about angle E? F. Now, let's start looking at what we have. So here's what we have going on here. Angle C, we don't know, but do we know angle G? What is angle G? 72 degrees. So if angle G is 72, that means angle C is also? Now, angle D we don't know yet. We're going to go to angle D last. But we do know something else. We agree angle E and angle F match up, right? So if angle E is 52, then angle F is also? Okay. However, we know one other thing. What do we know about the sum of the three angles in a triangle? They have to add up to exactly how many degrees. Therefore, can we get that third angle? You can. What do we have to do to get that third angle? We know the sum of the three angles has to add up to 180. Okay, you could do that. That's one option. All right. So an option 4x minus 12 plus 52 plus 72 equals 180. Okay, that's an option. I'll accept it. That's an acceptable setup. It's not wrong. Because the sum of the triangles has to add up to 180. The angles equals 180. That's good. I'll take that. I mean, it's a long way, but I'll take it. It's an acceptable way. And the reason being, if that's going to help you get a correct answer, what's worse, taking an extra minute to do your work and get a correct answer and maybe pass, or do it quick, get it wrong, you fail, and guess what? You gotta do extra work. You lose more time. So that's an acceptable option. I'm good with that. That's good work. And then the other way, of course, because what if you do 180 minus 72 minus 52? Is that another way to get? Is that another way to get our angle H as well? All right. So you have two ways to solve for the x. Because once you do 180 minus 72 minus 52, well, what's left? Do that subtraction real quick. What's left? Who could tell us? 56 degrees. Okay. Thank you, Andrew. You're right. So you could, since this last angle has to be 56 down here, this last angle up here also has to be 56. So that's another way you could set up your problem. So Noe, what you did was right. I kind of like your way too. Being, you know, the sum of the three angles has to add up to 180. And in the end, either 4x minus 12 equals 56 or 4x minus 12 plus 52 plus 72 equals 180. You will get the same value for x, either setup. So it's your choice. Either choice will work. But I just want everybody to understand how either choice will work. You have your study guide from last class? You're a smart man. All right. All right, that's okay. Well, all right. So get out your study guide. Okay, so here we go. But that's what you have going on here. The sum of the three angles has to add up to 180. Again, you have two options. You could either, once you know all these, if you know these two, you can just set up your equation like this. Or if you know the last one has to be 56, you could just use this one as well. So it's this one or this one. Those would be acceptable setups for me.
Is it this one?
Yeah. Now, anything you missed prior to this problem, you're going to have to get from Schoology or a friend or a neighbor or whatever. But you do need to understand what's going on there. All right, here we go. Now, did anybody try to find the value of x? Either using 4x minus 12 or 4x minus 12 plus 52 plus 72 equals 180. You get the same x value either way. Anybody get a value of x yet? I heard a 17. All right. It will be 17. Now, if you did it this way, I'm okay with it because the first thing you have to do is combine these three terms right here, negative 12, positive 52, positive 72. If you add those three if you combine those three integers, then you're, how much? So 4x. Say that number again? Check that. Let's check that. So you have negative 12 plus 52 plus 72. 112. Equals 180. Make that one a little more pronounced. So 4x plus 112 equals 180. Make that 112 a little more pronounced. And then if you do minus 112, minus 112, you would have had 4x equals 68. Now over here, and I'll show you in a second how this is going to get you the same thing. Divided by 4. Remember, divided by 4, there's where you get your x equals 17. Now, if you did it this way, if you did it, I'll just write it over here. 4x minus 12 is 56. Let's say if you took that route, if you add 12 to both sides, you're going to get 4x equals 68. And then we see in the end, both sides worked. Both ideas worked, right? Because in the end, you got 4x equals 68, both here and there. Divide both sides by 4. And there you go, x is 17. All roads will lead to this result. Questions? Now, next problem. You're going to have a couple problems. One, it's either going to be in a figure form. You're going to have to tell me what the missing value is, or you're going to have to draw your diagrams and then set up your proportions. Now, for similar polygons, using proportions. So I think I have, let me look at your, I'm looking at your final right now. So proportion, yep. So basically, when you have your proportion, so both of them are going to be in a, so you're going to have a problem that looks like this. Take the ratios, but then you're going to have to solve for the x. Or the other one, same thing. Now, here's what you need to do. I don't know if anybody remembers. So, whenever you have a proportion, okay, Okay, we're being this. Okay. Oops. Here's the setup for this problem. And you're going to have a similar setup for your other problem. And in both cases, well, on your test, you're going to have something that looks more like this one here. But for proportions, in both cases, what's the way to solve for a proportion? What do we have to do? In a little bit, but what's the first step before dividing? You need to. Who said cross multiply? There's what you need to do. You have to cross multiply. Cross multiply. So for the problem on the left, cross multiply. What's x times 25? 25x. I'm just going to write it down here. And then this side was 65 times 5. So 65 times 5. Well, okay, I'll do it like this. I'll do the original multiplication. 65 times 5 is going to be 325. So 25x is 325. Now, what do you have to do to both sides of the equal sign? Now you divide by 25. And 13 is going to be your result. Well done, Andrew. Yep, divide by 25. The other one's going to be the exact same idea. So you would have 4 times 25 equals 20 times x. But what's 4 times 25? Think about quarters. 4 quarters gives you $1. 20x. Now, how do we get the x? What do we have to do to both sides? There you go. Divide by 20. Divide by 20. And then what's our result? 5 is x. Good. All right, questions? Get that dive? Whatever you miss, you're responsible. Be considerate of the time. Questions? So get your setup. The setup is the number one thing here. You get the setup. Get your setup. You get the setup, then remember that's going to be a point right there, and then solve for your variable. Questions? All right. Here we go. Again, the key is getting it set it up. So more than likely, you're going to get something more like 7A. Tall, long, and then shorter board. Well, I should have said this one here, larger board. Smaller board. So I think I used the wrong words there, but you got the idea. Draw two figures. I'm going to give you the first one, but note where this matches. You have to go, if you go tall, long, that's how you have to do it. If you draw the pictures, put a fraction bar between these two sides, put a fraction bar between those two sides. There's your setup. Put an equal sign, boom. There's your setup. That's all you need. So you will get a card like that. Anybody have any questions? All right, here we go. Right triangle. So basically, here's your diagram. Because Joe needs to fix the roof of his outside wall. The wall's 15 feet tall. The ladder is 17 feet. Now, the ladder is always your hypotenuse. Did we get that, Norcus? Yeah. Ladder. Is that which side's our ladder? Okay, that's what I thought. So now, here's our setup. Use this formula right here, ABCs. So this is, oops. This is the formula here you're going to need for this type of problem. Now, remember the ladder is always going to be C. So for this type of problem, be aware, your ladder is always C. As long as you know that part, you're good. Then you're going to be all right. Because when we do our A squared plus B squared equals C squared, well, there's your picture up here. And then I always say use B as your base because base begins with the letter B. Does that make sense? Base B, same thing. So now, our setup, A squared. What number are we going to replace the A with? So now you're going to have 15 squared. Do we know what B is yet? So we're just going to leave it as B squared. But what about C squared? 17 squared, that's right. Remember, 15 squared and 17 squared are numbers. What's 15 squared? So it's 225. Plus B squared.
So how many questions are going to be on the final?
So what I'm going to do, you're going to have a certain amount, but you're not going to have to do all of them. I'm going to say I'm just going to throw an example. If I give you 30, you only have to do 25. Does that make sense? And the majority of it is multiple choice. Majority is multiple choice. Some it's going to be like those cross bubbles. You know how you have to pick exactly one for each row? That's how it's going to look like. We have 225 plus b squared equals 289. Now, what's our last step? Oh, no, that's not going to be our last step. But what do we have to do? The 225, can we add it to b squared or no? No. So what's going on with 225? Yeah, so we have to subtract 289 minus 225. Good job. All right, so you get 64 for b squared. So Andrew's 100% correct. You got b squared at 64. But are you done? Why not? You need b, but how do you get b? You have to square root the 64. That's what you need to do here. You're not done because you got to take the square root of 64. So what would be the square root of 64? There you go. So square root. Oh, I think you might have hit square by mistake. So you have to hit the second, then the x squared button. That's how you're going to get the square root symbol. That's okay. So what would have happened was if you accidentally hit square rather than square root button, let's say if this was a 4-point problem, then it'd be, okay, you get 3 out of 4 points. Because the biggest part is getting here. But I'm going to give you a major hint. Your ladder is always the longest. Ladder is the longest, so the ladder will be C. Just think about any picture. The ladder going towards the roof. It's always that angle. It's always the slanted side. That's always going to be your longest slide. All right, questions? All right. Now, the next few things I'm worried about is our right triangles, long, long leg, short leg, hypotenuse. Because the next at least 2 slides are going to be super important. They're probably going to be some of the hardest problems. Oops, did not mean to go all the way down there. We'll get to that one in a moment. No, although I kind of want to talk about that one too. Okay, this is the one I'm worried about. All right. So, final questions on setting up your Pythagorean theorem. All right, Eric, you got that one? All right. Next one I want to talk about. Here is what will happen. You're going to get a 30, 60, 90 triangle. I'm telling you that right now. However, I'm either going to give you the short leg or the hypotenuse. I'm not going to give you the long leg. Because as we know, the long leg was the hardest part of the whole thing. If I gave you the long leg, however, if I gave you the short leg or the hypotenuse, your life got easier. Because, for instance, if we started with the short leg, all you're doing is just multiplying. Now, the question is, do I multiply by 2? Or do I multiply by the square root of 3? So, and the short leg is always across from the 30-degree angle. So that might be something to think about. .30°. I'll make it smaller. Oops, the short leg rather. So the short leg was always across from the 30° angle. That's the key. No. Short leg is always across from the 30° angle. Long leg was across from 60° angle. And the hypotenuse was always across from right angle. So now, I apologize, it's going to be small. Somebody's out, you got to wait. So that's what we have going on here. Short leg across from 30° angle. So you're either going to get it where, I'm looking at it, you're either going to get the short leg or the hypotenuse. So that's what's going to happen. Now, make it easy. So if I gave you the short leg, say this problem's short leg is 5, all you have to do, if you want to go from short leg to hypotenuse, multiply by 2. So then what would be 5 times 2? So your hypotenuse for this problem would be 10. And then to go from short leg to long leg, take your short leg, multiply by the square root of 3, and you're done. I cannot. Or similarly, if I give you the hypotenuse, which I gave you here, first off, to go from hypotenuse to short leg, just divide by 2. So for the second triangle, what is 6 divided by 2? What's 6 divided by 2 going to give us? 3. And then to go from short leg to long leg, just multiply by the square root of 3. So that's all you do. I'd worry more about the short leg hypotenuse relationship. That's the one I'd worry about the most. So I'll let you all look at this one for a moment. You're going to get something of this type. Either I give you a hypotenuse, get the short leg, then the long leg. Or I give you the short leg, you get the long hypotenuse, and the long leg, just multiply. That's all. But if you get the hypotenuse, divide first by 2 to get the short leg, then multiply by square root of 3 to get the long leg. But always know, hypotenuse, short leg, know that relationship. Hypotenuse, divide by 2, short leg. Short leg times 2, hypotenuse. That's the big one. If you understand that relationship, then you're in good shape, because then to go from short leg to long leg, just multiply by square root of 3. All right, questions on this problem? You're going to get one of these two. You will get one of those two problems. I guarantee it. All right. Questions on this problem? Again, know the relationship between short leg, hypotenuse. Okay, hurry up. You don't have a whole lot of time. All right. This one here. This one was definitely the tough one. As I remember this unit, this one was a struggle. Maybe it was because we took it towards the end of a quarter or something. I don't know what. This one was this one was tough. What you need to do on your triangle, you're going to get something that's such that you're going to have to use a sine, cosine, or tangent. But the most important part is identify the non-right angle, because that's going to help you determine which side is opposite, adjacent, with respect to the angle. Now, the hypotenuse will never change. The hypotenuse is always where? Or always what? Who can tell us where the hypotenuse is located on a right triangle? Okay, well, this is it's across in the right angle. Look, so your right angle is here. Here's your hypotenuse. And on your final, it's going to look very similar to one of these guys. But now the other part is, we're going to do a little bit of practicing. So for instance, this problem here, here's our angle. Here's our angle right here, 53 degrees. This is our angle. Now, this 45, is the 45 adjacent to the angle or opposite of the angle? Look where this 45 length is. Does it touch the angle or does it not touch the angle? Look where 45 is. Does it touch this angle or not? The 45. See this side right here. Here to here. Does this side touch this angle? Touches. That's an adjacent. So now you need to determine. I have a hypotenuse and an adjacent. Again, what two sides are given to us? You're given the adjacent and a hypotenuse. Therefore, which one of these, sine, cosine, or tangent, has an adjacent and a hypotenuse? Cosine. It's cosine. That's the one we use. So it's a cosine of your angle. Well, this is going to be your setup. What's the cosine? What's our angle measure here? What's our angle measure for this problem? 53. So it's going to be the cosine of 53 equals. All right, do we know that? So what's going to go on top? So it's going to be cosine. It's going to be adjacent over the hypotenuse. What's the adjacent value? That's our angle. 45. Do we have a hypotenuse? Do we have that yet?
No.
No. So that's our variable. Do we have enough information though to solve for this proportion or this problem? Do we have enough information? You do, because in the end, the cosine of 53 is a number. You need to type in the cosine of 53 in your calculator. You should get a number. If you don't, let me know. Anybody type the cosine of 53 into their calculator? 0.99. Say that number again. Okay, so 0.918. We'll say 0.918. Okay. Or 0.91. Was it 0.9? Noe? Oh, okay, hold on. We're going to have to look at your calculator because it should be positive. It's not your fault. I think they went radians versus degrees. All right, I'm going to use your calculator too, Alexandra. Okay. So what you're going to have to do, ladies and gentlemen, you're going to have to go to the mode, go down to where it says radian, right arrow, the degree. Now it should work. Now we did cosine. And you should get, that number should be positive. You're not sure how, what, all right, hit enter. I think you might have gotten it right. Oh, okay, all right, we'll fix it. All right, hit clear. All right, so go to mode real quick, Andrew. Go down, yep, hit enter. Right here, yep. Now do cosine. No, just regular cosine, sorry. Then type in 53. That's the number. You gotta open up your calculator. Hey, what's up? Open up your calculator. You got it, Tránsito. All right, did you get that number, Joey? That's the number. Araceli, okay, go to where it says radian, so go down 2 spots. Go to the right, hit enter. And then, yep, go to, hit quit, okay, good. Okay. Try it again. Oh, you don't need it twice, just hit it once. You got the right number, so that's cosine 52. Okay. I don't know why we're dealing with that. All right, so the cosine of 53 is going to be at 0.6 something. So you had 0.6 something. What was it 0.601? Who got that number? Somebody read that number again. Cosine of 53 with 0.6 what? 0.601. All right, so that was equal to 45 over K. I know I'm running. And then you would just solve. Well, this one would be a little funny because actually, what I would tell everybody to do, you can always write this over 1. Then the quickest way to get the K value, just divide 45 by, just divide 45 by 0.601. So you would actually do it like this, 45 divided by 0.6. What would you get if you divide 45 by 0.0601? Anybody try that real quick? 74 point something? 74 point. We'll say 74.9. I'm just rounding to 1 decimal, but you're right. This is okay. You know why? Is this length longer than the 45? Then you're good. You got it. Now this other one, I'm just going to show you. Here, you have an opposite hypotenuse. So you don't have the adjacent. So then okay. I hope, if you can wrap ideas on how to pass the test, then I'm all ears. If you only have an opposite and a hypotenuse. Okay, Dennis. Okay, that's enough. Opposite over hypotenuse. And then you would have the sine. Now you can take your angle, 35. And then this one, you could actually, this one's going to be easy. Because again, just do your diagonals. And basically, if you multiply 17 times sine of 35, you're going to get your x. So. Sorry, it's a little bunched up. You should get a number. So if you multiply 17 times sine of 35, that's going to be where we're going to stop today. So real quick, anybody get that number, 17 times sine of 35? You should get something less than 17. Anybody get that number? So 17 times sine of 35. Anybody get a number? What do we get? 9.75. Okay, so it'd be 9.75. Oh, okay. All right, here's the deal.